So good morning, everybody. I welcome you to the PhD defense of the candidate Ediclê de Sousa Fernandes Duarte of our graduate program in climate sciences of the Federal University of Rio Grande do Norte. I welcome first of all the examination board, starting by Ilan Koren from the Weizmann Institute in Israel, Hendrik Elbern from the Rhenish Institute for Environmental Research of the University of Cologne, Maria de Fátima Andrade from EAG from the University of São Paulo, Tassiana Toledo from the Federal University of Minas Gerais, and Nilton Rosario from the Federal University of São Paulo. You're all very welcome. And Claudio as a co-supervisor, Claudio Moises of our PhD program, and here from the Federal University of Rio Grande do Norte also. So we will start this defense by a 40 to 45 minute presentation of the PhD candidate. So Ediclê will present his work to us. And afterwards we will have a discussion and maybe make a very short break for water and then continue with the discussion of the thesis. So I will be short. I will just hand the word to Ediclê for his presentation. Please, Ediclê.
Okay, let me share my screen.
Okay. Good, okay. Good, okay.
So first of all, I want to say thank you for the examining committee for accepting to read and evaluate my work. We have great scientists here, which make me a bit nervous, but it's very challenging for me. So I want to, my work is about modeling and assimilation of atmospheric aerosols over São Paulo, Brazil, with the regional chemistry transport model EURAD-INVERSE on a high resolution. So my presentation is divided as follows, starting with introduction, which involve motivation, challenges, hypotheses, objectives, the methodology that I used to develop my work, and also the results and discussion, and the conclusion with conclusion and outlook. So first of all, what motivated me to develop this work? It's about air pollution. And when you talk about air pollution, we cannot talk about atmospheric aerosols. Air pollution is caused by solid and liquid particles suspended and gases suspended in the atmosphere, and we call them atmospheric aerosols. Some of these particles are emitted directly from their sources, which we call primary aerosols. Other can suffer some physical chemical reaction in the atmosphere, and we call them secondary aerosols. Aerosols impact not only on air quality, but also in climate change. And the long-term exposure to atmospheric aerosols in high concentration can cause cardiorespiratory disease. So that's the main importance to study them, because it has a direct effect on the health of the population. So at the same time, some types of aerosols can also impact on Earth energy and radiation budget. So that means that it's affect immediately on air quality, but also in a long term, it has their impact on climate change. So when you have dense urban areas or mega city, occasionally you have a large emission of aerosols due to cars, due to industries and agriculture and other stuff. So we have a lot of anthropogenic emissions directly emitted to the atmosphere. And megacities tend to be global risk areas due to their dense concentration of people. Some data shows that 54% of the world population lives in urban area nowadays, and it's projected to increase to 62%, which is 5.4 billion people by 2035. In Brazil, we have more than 85% of the Brazilian population living in urban area. So consequently, we have a decrease on air quality. This is a typical pollution at MASP, where we can have here a layer of air pollution, a very dense one. And at some times, this air pollution is not only generated in the city itself, but also is transported due to the longer range transport. And in the case of São Paulo, in 2019, we had an abnormal concentration or abnormal transport provoked by the biomass burning activity in Maya and Amazonia basin, causing, making the day get dark in August 19. So this event was called the Black Rain, and was caused mainly because of biomass burning aerosol that was transported to São Paulo and mixed it with the pollution emitted by the city itself. So at MASP, we have a very dense urbanization, which is composed by 21 million people living there. Consequently, we have emission of greenhouse gas and pollutants that's mainly because of 40,000 industrial plants distributed in the metropolitan area of São Paulo, and also 7 million private vehicles. As a consequence of this large urbanization and large emission of pollutants, we have some phenomenon like thermal inversion, heat island, and pollution, and also some effects in the climate change. Consequently, we also all this problem can affect the life quality of the population. So that's my main motivation, because it's quite important to study this the air pollution or the aerosol behavior in megacities. So the main challenge it was I tried to answer some question like how does longer range transport of air pollution impact at the metropolitan area of São Paulo, and also where these pollutants came from, and do mass pollution reach other cities in and out of São Paulo state, and how can the vehicle emission inventory from the vein model improve radiant performance, as well as can the 3D VAR data simulation improve numerical model performance, assimilating aerosol data for mass. So my hypotheses are that part of the pollutant concentration over mass come from somewhere else. The air pollution of mass is substantial aggravated by the long range transport of pollutants, the vehicular emission model that produce the inventory for transport produce high resolution traffic emission, improving the model performance, formerly based on EDGAR only. And the assimilation of observational data improved the model performance. So the main goal of my work was to adapt the EURAD-INVERSE model for simulation over the South America, especially over Brazil, nested with a high resolution of 1 kilometer over the metropolitan area of São Paulo, and further adapted its 3D VAR data simulation system to assimilate particulate matter from Tese measurement station. The specific objectives was to simulate the meteorological fields with WRF model for all 3 grids for the month of July and October, and also to prepare the emission from EDGAR inventory version 4.3.2 to be used in EURAD, as well as the emission in high spatial resolution from VANE. Model version 0.2.2 to simulate 2 case studies using the EURAD-INVERSE model and evaluate the model performance with the full EDGAR emission dataset and also with a terrestrial transport emission from VANE. And also to compare simulation with observational database from Tese monitoring station, as well as with available LiDAR data. So there's more objective is to run EURAD-INVERSE again, but now with assimilation, assimilating PM 2.5 concentration from Tese monitoring station into the model with a 3D VAR assimilation technique, and also to evaluate the performance of the models analysis after assimilating and evaluate how the assimilation technique improves the model estimates. And also we identified which further development may improve the model performance for future use of the data simulation technique in South America. So now I'm going to start my methodology. So EURAD-INVERSE is an advanced numerical model system able to simulate the physical-chemical evolution of trace gases and aerosols in the troposphere on a regional scale. The EM, which is inverse model, indicates that the model has been advanced by an inverse part for data simulation. So if you give emission and meteorological parameters, the model forward in time compute advection, diffusion, chemical convection and deposition in both aerosols and also in the gas phase. So the aerosols species are treated in MADE, aerosol dynamic module for Europe, and the MADE mailing transform are responsible to calculate and transform the emissions from EDGAR and other inventories in concentrations of pollutants. If the variational data simulation is applied, the model uses available observation, firstly prepared in the prep processor, and can be assimilated in the model. And the EEM act as an interface between emission data available and for certain areas and periods and the CTM. Yeah. So the meteorological fields was generated using the WRF model for the 3 domains. The first domain with a 25-kilometer resolution. The second one centered over São Paulo state. Oh, I'm sorry. over São Paulo state, and third one with 1 kilometer resolution. So that's my meteorological configuration, where I use it the GFS data, and with a resolution of 0.25 degrees, and with also 35 levels, vertical levels, that the first layer, it goes until 35 minutes or meters, and the last one up to the 100 HPR. So that's my main parameterization, and it was based on, I'm really sorry. It was based on previous studies such as Andrade et al. 2014, Varavella, Albuquerque. So since I was applying for the first time EURAD-INVERSE to the southeastern Brazil, I thought that maybe using this set of parameterization that was firstly used by other work, I think it would be a good way to evaluate a EURAD-INVERSE model to São Paulo. So the emissions inventory comes from the global air pollution emission, EDGAR, version 4.3.2, and the main focus was on primary particles, which include PM10 and PM2.5 and carbonaceous speciation, with a resolution of 0.1 degrees. Also, a second simulation was performed using EDGAR, and I substitute the vehicle transport emission from EDGAR by the high resolution spatial and temporal resolution from VEN, with a resolution of 1 kilometers. For chemical and boundary condition, I use it Copernicus atmospheric monitoring service analysis from the ECMWF. So data simulation combine modeling with observation data to produce the most probable representation of the state of the atmosphere. So the main goal of the data simulation is to solve the cost function, which is formed by the initial values or the initial state of the model, and the background information. Just to be clear, the background, it can be a climatology, or it can be also a previous simulation. In my work, for example, I use it as background my simulation using EDGAR and VEN. So this is my background information, and B is the background error covariance matrix here. So the second term of the cost function is based on the initial values and the observation. So the data simulation includes the observation in the model to try to approach as much as possible to the real state of the atmosphere. And for this, it takes account the observation error covariance matrix, which include representativeness errors, measurement errors, and everything is processed by the forward observation operator. So the main objective is to solve the cost function. So for this, we try to minimize by several interactions until reach the minimum state. So and the minimum the solution is to sort iteratively by performing several evaluation of the cost function and its gradient. with the objective to minimize the distance between observation and the model. When we minimize the cost function, the final result is a blue analysis, which we call the best linear and based estimate. So that's my methodology. Now I want to show you some of my results that I achieved. So the first I tried to see the behavior of the atmosphere that can cause the longer range transport from other regions of Brazil to São Paulo. So the meteorological condition for these days, July 10 until July 13, was that we have two low pressure system acting over Bolivia in the south of Brazil. And we can see here the South America low level jet at 850 HPR, which is more or less 1.5 kilometers high, and we can see that it passed over São Paulo city, that it's here. And this South America low-level jet brings not only humidity to the south and southeast Brazil, but also it brings aerosols to this region of Brazil. So here, usually July, between July and October, it's the wet season, it's the dry season in Brazil. So we have a lot of biomass burning activity in the Amazonia Basin, central Brazil. It can be seen by the fire hotspot here. And also LiDAR profile shows that it's centered in the city of São Paulo at the University of São Paulo. We can see that the first layer here represented by the PBL, and a second layer between 1.5 kilometer and 2.2 kilometers, a layer of aerosol possibly came from someone outside of MASP. So we have a layer of aerosol here that is related to the long range transport of pollution. Of course, that the city itself contributes to this pollution at between 1.5 and 2.2 kilometers. And there is another layer here between 4 and 5 kilometers that is related also to the long range transport pollution. So with the objective to see how my model is simulating over São Paulo, I performed an evaluation of the 4 meteorological variables that was performed in the model, and I compared with CETESB station, CETESB meteorological station. So mainly I achieved these values, which I evaluate using some statistical indices like the root mean square, percentage bias, and the Pearson coefficient. So here we can see that the root mean square that indicate if the model fits or not in the behavior of the observation. We can see a low root mean square in the temperature and the relative humidity, which indicates that the model fits the observation. And here for wind speed, the model fits the observation, although the bio was a bit high, which indicates that the model overestimates the wind speed. And also the root mean square indicate that the model did not fit or did not correctly simulated the wind direction. This can be more visible in the graphs Here, the red line is the observation, the black line is the WRF simulation, where we can see the temperature, and we can see that the model simulated very close to the observation for temperature and relative humidity. For wind speed, we can see that the model overestimate wind speed, and for wind direction, it was very difficult to be represented in the model, which does not invalidate the model. It's just that it's difficult to simulate wind speed and direction near the surface because the model has its own limitation. Looking at the intercomparison between different inventories, this is the total annual emission and emission sectors in tons per year from Edgar inventory for PM2.5, where here we can see the total annual emission of PM2.5, and also the annual emission of, from the transport sector here, which we can see for the 25-kilometer domain that São Paulo is the hugest emitter of transport of PM2.5 to transport. And also we can see the agriculture sector that is also mainly responsible to emission of PM2.5. So we can see here that in the interior of the state, there's a lot of emission provoked by agriculture sector. And for PM10, we can see a lot of activities here, and mainly related to the agriculture sector and also waste treatment and disposal. So the longer range transport, it can be seen in this GIF here, where we can see the transport of pollutant reaching transport, and this plume of pollutant came from central Brazil and other regions of Brazil, and it can really pass over São Paulo. And so we can have here pollutant transport from central Brazil and interior of São Paulo state to the metropolitan area of São Paulo. It also can be seen the pollutant transport from the metropolitan area of São Paulo to the metropolitan area of Rio de Janeiro between July 12-13 at 5 kilometers away. So this was well seen also in 1 kilometer domain, where we can see here the pollution really reaching São Paulo, and this pollution come from the inland of São Paulo and also from outside São Paulo state, and pass over Campinas and mix with the pollution produced also in Campinas, that it's an important metropolitan area out of MASP. And we can see here the contribution of Santos, which is an important industrial area for the state of São Paulo, and produce a lot of PM2.5 and PM10 and other pollutants. So, and we can see, I calculated here the contribution outside MASP to MASP, and also the contribution from MASP to that passed to Vale do Paraíba, and also the contribution from MASP to Santos metropolitan area. So I calculated these, taking into account the wind speed and direction and the flux of mass between these four regions here, and I achieved the result that the contribution of PM2.5 from the area of São Paulo was 50% of the total mass of PM2.5 in the mass at 850 HPR. And of this total PM2.5 at mass, 21% contributed to increase the concentration of PM2.5 at Vale do Paraíba. And also 50% of the total PM 2.5 from us contributed to increase PM 2.5 over Santos at 850 HPR. Okay, this was roughly calculated. It was just an estimation. At surface level, I compared the Edgar emission and the Edgar using vein emission. So it can be seen here that Edgar increase the PM 2.5 concentration in the main area of the city where we can have a concentrated region in a high volume of traffic. So, this is the main goal of vein, where we can see in the main traffic areas high concentration of PM 2.5. I also statistically compare the observation outside the MASP. So I divided some CETESB station clusters, for example, Limeira, the Northwest Limeira, that is composed by 2 CETESB stations. In Campinas, I have 4 stations, so I divided in 2 groups that I thought would have some chemical similar chemical regime, and also Vale do Paraíba and the main CETESB station at MASP, and calculated some statistical indices who says to me how my model are simulating for this region. So I conclude that the bias varied between 8 and 40%, which means that the model, the negative result, it means that the model underestimate the PM 2.5 at this cluster outside MASP. At the same time, the correlation coefficient varied between 0.55 and 0.68, which indicate a good correlation. The RM's, the root mean square varied between 17 and 30%. Which means that the model varied in most of time inside the standard deviation of the observation. At MASP Center, I compared the Edgar and plus vein and with the simulation with Edgar alone. And we can see here that the vein emission improved the result at MASP for PM10 and for PM2.5, and improved all the statistical indices. So, and when we look at for the time series of the region, we can see here that with vein, the model stayed inside the standard deviation of the observation. So the second case study was performed during October 22 to 25, which is characterized by the transition season from dry winter to wet summer in the southeastern Brazil. And the meteorological conditions for this day at 850 HPR indicates a high pressure system acting over the ocean here, and usually a high pressure system is related to it provokes atmospheric stability in the region, and consequently it can worsen the air pollution in some region, since the pollution stayed trapped in the atmosphere. So, and this was seen when we look at to the LiDAR profiles, where we have a dense planetary boundary layer carried with full aerosols, and also a second layer between 1.2 kilometers and 2 kilometers, which is which can be brought by the winds at this high. So I can say that probably it's a pollution that came out from outside MASP. And also a third layer here between 2 and 3 kilometers. So I validated the same meteorological variables at surface for this time, and I achieved some very interesting results here that temperature and relative humidity were represented by the model, but wind speed was overestimated, and wind direction was difficult to be represented at the surface, as we can see the root mean square and the bias results. And at the same time, we have a poor correlation for wind speed and wind direction. When we look at the wind rows here, we can see that there is a shift between what is observed, what was measured in surface by the meteorological, Cetesmo meteorological station, and what was simulated by WRF for this period. So for October, we had a different situation, and actually was the opposite situation from July, because we can see pollutant transport from Rio de Janeiro, and mainly the metropolitan area of Rio de Janeiro, being transported to São Paulo via Vale do Paraíba, and also through the coast. So so we can see the pollutant exchange between the metropolitan area of Rio de Janeiro and also the metropolitan area of São Paulo. At the same time, the pollution that is produced by São Paulo city and the Santos port, it can be transported to other region like to the interior of the state, or also some state like Paraná and even Rio Grande do Sul. So I calculated this using the same methodology, the contribution that comes from through the Vale do Paraíba. Vale do Paraíba is also an important industrial area of São Paulo. So it also contributes to the pollution transported to MASP, but I focused on the pollution that was coming from Rio de Janeiro. And I concluded that 28% of the total PM 2.5 at 850 HPR are coming from the Vale do Paraíba, and also the pollution that are reaching MASP through Santos. And Santos contribute with 34% of the total PM 2.5 for these days. So I think it's necessary to understand and how often this happen, because it's an increase of pollution at MASP due to the long-range transport. So at surface level, we can see here the impact on vane emission over São Paulo and the Edgar emission. The vane emission, as expected, increased the PM 2.5 concentration at surface, mainly in the traffic areas. And I also validate my the model with observation, and for the cluster outside MASP, we have a low bias, which means that varying between 2.9 and 41 for certain areas, and we have a low root mean square, which means that the model fits the observation, and also a good correlation for some clusters. For MASP center, the model presented a difficulty to simulate and to calculate the concentration of PM2.5 when we compare to the observation. And we can see here that Edgar and Vane overestimate more than 100% at MASP. But even when I used only Edgar, this concentration was also overestimated. Although the root mean square shows that the model fits the observation in a good way. So the model can follow the behavior of the PM10 and PM2.5 concentration, but the concentration was overestimated. So we can see here by the time series of PM10 and PM2.5, the red line is represented, is the Vane performances, and the blue line is Edgar performances. So, and to close my result, I also performed, used the 3D VAR scale from EURAD-INVERSE to calculate, to simulate PM2.5. Since data simulation takes real data and put on the model to be more close as possible to the real state of the atmosphere, it takes account some of important variables here, that is the measurement error, representativeness error, and the radius of influence. The radius of influence are responsible to spread the observation information to all direction in an homogeneous and also isotropic way. So I basically assimilated 4 stations, that is Marginal Tietê, USP, Grajaú Parelheiro, and São Bernardo dos Campos, that is outside the city of São Paulo, but inside the metropolitan area of São Paulo. And I also, I did not assimilate Congonhas, Ibirapuera, and Dom Pedro II, because I was trying to see how much the concentration of São Paulo, at USP and Marginal Tietê and this other station can influence in the concentration of this other in this other region, in this other station here in São Paulo. So I basically adopted 15% of the measurement of the relative error, and my experiment involved 2 simulations. One taking using 1 kilometer radius of influence, and other with using 2 kilometer radius of influence, and performing with the same error. In the methodology, I committed an error because I put there that I used 15% and after 25%. So I'm sorry for that. It was an error that, but I used the same error for both simulation. And I compared with the background information and the observation information. So this is the background information. The background is my first simulation for July 10, 13, using Edgar in Vane emission and calculating the concentration. So the dispersion graph here shows the observation compared with the background. So we can see that the concentration are very dispersed. But when I used the analysis 1, which is my first analysis using 1 kilometer radius of influence, we can see that at USP, the PM2.5 was very aligned to the red line, while at Marginal Tietê, it presented a difficulty to be aligned in the red line here. So at USP, the second performance using a 2-kilometer radius of influence, we can see here that the model are close to the red line here. And while at marginality T, we have an improvement better than using 1-kilometer radius of influence for the region. So the statistical analysis say compared with comparing the background with 1-kilometer radius of influence here and 2-kilometer radius of influence here, we can affirm that using 3D VAR, all the statistical indices were improving. So the assimilation improved all the results. And we can see here by evaluating, for example, the indices of agreement or even seeing the correlation coefficient, which in the background was 0.47. And after assimilation, we have a result like 0.86 and 0.87. And also the bias, we have low bias here, low root mean square here. And for marginality, we have that using 2 kilometers radius of influence, the results were way better than using only 1 kilometer radius of influence. For the other station, we can also see a significant, an important improvement when we compare the background information with observation here and the at Grajaú, the analysis using 1 kilometer radius of influence, we can see that the perfect match is mainly when we use 2 kilometer radius of influence where the results are more close to the red line here. And when we look at to the statistical indexes, we can also see for some for these 2 station improvement of some statistical indexes like the correlation coefficient, the Pearson coefficient, the index of agreement, the error, the mean absolute error here, the root mean square improved for both stations. So this is an experiment, my performance as represented by the graph here. This is the background, and this is the simulation using 1 kilometer radius of influence, where we can see here the region of influence smooth, the PM2.5 concentration in the region, and when the error of the observation and the error of the model are too different, or the concentration, for example, at marginal TNT calculated in the observation was more than 5 times higher than the background formation, the model pushed through the background in the analysis using 1 kilometer radius, while using in the 2 kilometer radius, the concentration stayed almost in between them. So this is an important impact of the radius of influence of some region. It can improve the analysis for some regions. And also, here's the increment. It's made calculated when you take the analysis and minus the background, we can see how the simulation improved the concentration in the region and how it's being transported to other region and influenced the region around it. So this is the impact that I was trying to see when I assimilated this station here, and not the other one here that is mainly composed by Congonhas, Ibirapuera, and Dom Pedro II. So at this time here, October, sorry, it's not October, it's July 10 at 22 local time, we can see that the analysis improved the results at this time for Ibirapuera and Congonhas station. And we can see this when you look to the increment here, where we can see and transport from this station through this influencing this other station here. So another experiment here, as we can see, the difference when we use different regions of influence. So it's necessary to understand how the regions of influence can be important to the analysis and the different representativeness can be the key role to use correctly the data assimilation system. Since the analysis can push the through the background if the regions of influence are not correctly used, or it can push to the observation, which is which the model understands as the best close to the reality. So my conclusion was that this has been the first time that 3D VAR chemical data simulation system has been adapted and used in the MASP to assimilate TESE data. EURAD-INVERSE elucidates well the role of the South America low-level jet in this long-range transport of particulate matter, contributing to the deterioration of air quality of MASP. And also, the EURAD-INVERSE results shows that the pollution generated by MASP in Santos Coast can be transported to other regions, such as the metropolitan area of Rio de Janeiro, and also in over the Atlantic Ocean. And all statistical indices indicate that with vane emission, the simulation performs better than the simulation without vane for July 10-13, which has a meteorological condition different from October. In the second case study in October 22 to 25, EURAD-INVERSE simulations show air pollution transported from the metropolitan region of Rio de Janeiro to the metropolitan region of São Paulo via Vale do Paraíba and Rio de Janeiro. For MASP Center, October simulation strongly overestimated the observation for PM10 and PM2.5. And in addition, these two case studies also shows that EURAD-INVERSE requires better emission inventories. It's always excellent when we have good emission. Comparison of the assimilated PM2.5 against observation and the pure model simulation, which is the background, demonstrate that with data simulation, the analysis approach to the observation of PM2.5 during July 10-13 and presented a strong correlation. Since data simulation also affect the surrounding areas of observational sites, choosing homogeneous and anisotropic regions of influence can help to understand how neighboring stations interact with each other. And also, the land use parameterization can be the main cause of the poor representativity of wind speed and direction for both cases, impacting in EURAD-INVERSE results of PM10 and PM2.5. So for future works, I would say that the EURAD-INVERSE 3D VAR scheme has been developed to assimilate additional observation from aircraft and satellite, as well as other air pollutants such as PM10, ozone percussion gas. At the same time, and since it was adapted, it's working already over São Paulo, it can be done a plethora of other studies using the same tool. And with more observation types assimilated, this data simulation system is expected not only to further improve the model performance, but also to be used in other applications, such as air quality trends, define responsibility for air pollution levels, study emission reduction scenarios, and even to use more advanced data simulation techniques provided by EURAD-INVERSE, which is for the VAR. So I conclude my my presentation with this message: take a step, however small, and reduce air pollution. I want to say thank you for your attention. So, yeah.
Okay, thank you very much, Ediclê.
Thank you.
Can you stop sharing your screen, please?
Yes, yes.
Okay, thank you. So, just let me take notes here. Okay, so we will go over to the discussion part now. So I want to ask all members of the examination board whether you want to take a short break or do you want to continue right away? Any opinions? Is it okay to continue? Continue, okay. All right, so, okay, since we are a big board, I thought that we could try an innovative approach to this discussion round. So I would like to suggest, as I sent you an email about it, but just to explain. So I thought that we can start with the general comments. We make a first round with general comments and a few, 2, maximum 3 more specific comments or questions to Ediclê. And we make a first round like that, and then afterwards, if there are still open questions and comments, we can go for a second round. I thought maybe it's more time effective to do it that way and give it a try. And so I would suggest the order, if you all agree that, well, by tradition, the external members from abroad, they get to speak first. So I would suggest that we start with Ilan, and then Hendrik, and then Maria di Fatima, and then Tatiana, and then Nilton, and then Claudio as a co-supervisor would speak last. Okay. Is that okay? Okay, good. Then I will give the word to Ilan, please.
Okay, thank you. Thank you for the invitation to be in this board and to hear this very nice presentation. Well done, Ediclê. It's beautiful. And I have to congratulate you that you are a very brave person. Taking a model that was developed in Europe, was tuned in Europe, was calibrated in Europe, a very, very sophisticated model that includes, of course, dynamics, thermodynamics, chemistry, aerosol chemistry, gas to particle, all the chemical processes, sink sources, and you took it to South America. So I think that it's a job for 10 PhDs, not 1 PhD. And I'm very surprised that you have such beautiful results already so fast. Because if you would ask me like in advance, how long will it take to calibrate a model that was developed in Europe to a different place and so different, with different methodology, different aerosol types, different problems, I would guess that it will take much more. So beautiful. I think that the stuff that you are showed is already a big achievement. And it can be used, and now it can open a research venue for many more studies. So well done. And not only that you moved to South America, I think that you took the area of São Paulo, which has very special challenges because you merge topography, so you have orography, you have contribution from the interior, from inland, you have marine atmosphere that reach Sao Paulo, of course. You have very complicated dynamics, very complicated meteorology. You have clouds, you have a lot of interactions there. You have, as you said, long-range transport, aerosols, smoke, agriculture aerosols that are coming from the interior, mixing with the local urban industrial aerosols. I would never do such a project. You are very brave.
Thank you very much.
So well done. And I'm very impressed with the results because, you know, taking such a project and showing in many ways, many results, many very nice results. And of course, we can learn a lot from the deviation from the observations. So I think that any deviation that you show from the observation is actually opportunity to learn more. So your best information is not the good results, it's the bad results. This is the best information that you can gain from such an exercise. So you have a lot of different venue to do more research. And now, specifically, you know, your high resolution grid was 1 kilometer resolution, right?
Yes.
Do you have information about the structure of the street, the structure of the buildings, the structure of whatever is going in downtown Sao Paulo? I mean, this should have a huge influence on your results. I mean, yeah. Especially if you take the ground stations that measure PM, and I would guess that the structure of the street would be a huge factor on what you measure there. So it's a very local and very convoluted problem that you take there. What information can you put on one kilometer resolution?
Yeah, that's a great question. First of all, thank you for your comments, Ilan. It's quite important to hear from you. And yeah, it has been a huge challenge to adapt this EURAD-INVERSE model to Sao Paulo because of its complexity. And I had a lot of help from Hendrik and his group, which is composed by excellent scientists like Annie and Philip, and they were available to help me in everything. And it was nice to learn with them and to get in contact. It was challenging because I get there with a lot of difficulties, but they helped me in everything. So I think that for mesoscale alpha model, it's very challenging when you simulate with 1 kilometer resolution. Not necessarily it will simulate well just because of this resolution, since it's necessary to have a good land use for the region. And worth land use, I think it's not updated for mega city of Sao Paulo, so it's necessary to adopt new land use for the region to have a better representation in the model, to be better simulated. So it's I think that it's also difficult to represent the main variables near the surface because of the complexity of the terrain, because the buildings and the cliff in Sao Paulo, and all of these difficulties that for a mesoscale alpha model, it cannot be, there is a limit So higher the resolution, higher the computational cost, and consequently it's difficult to be represented. I think that also it's necessary to perform more sensibility test using this resolution for the region, and I need more time to perform other simulation with different parameterization for the region, since it's difficult to perform the simulation using only one set of parameterization that can serve that can work for meteorological condition very well, and for another meteorological condition it can be very difficult to be simulated or to be near of what we expect. So I think it's that. And using high resolution emission, of course, it can help. But if meteorological wasn't correctly performed, it can have an important impact on the final concentration of the pollutants. So that's what I learned so far. It has been challenging to adapt the model, but now that the model is working, it's necessary to fix some points in the model to have a better representation for the area. So that's my opinion.
Okay, you did do it. Do I have another time for another question? Okay, so I will ask only the large scale questions, and I leave the details to later, or maybe to very later. You show from your analysis that actually I'm very excited by errors. So I prefer errors on good results. Good results are boring. So you show that you have errors in the methodology. You have errors in the long-range transport. You have errors in the sources, in the in the evaluation of your sources, right? You have errors in the chemical processes. You don't know if you represent well all the chemical processes, all the particle, gas to particle transport. Maybe yes, maybe no, I don't know. You have a lot of errors here. And I think that the challenge would be to find the main error. What would be the main reason for the deviation? And what would be kind of second order that you could deal later? So what is your opinion among all the gallery of possible errors that you have in the emission, in the long-range transport, in the methodology, in the way by which WRF is using the dynamics? You know, you compare a surface wind. Surface wind is terrible. Surface wind is affected by the buildings. I wouldn't trust it I will never trust it, you know? If you could take a radio standard and take winds from high above and compare them, it would be much more useful. There is no point to compare surface wind. It's so local. It's so very local that I don't expect it to be good. So, you know, among all the problems that you described, what would be the core? From where do you need to start in order to improve the performance?
I would say that the land use in the region, it's the roughness of the land. It's very difficult to be simulated in the model, and this, as you said, this can cause some errors in the dispersion near the surface. So the land use affect not only meteorology, but consequently affect the final calculation of the concentration and the distribution of the concentration of this pollutant near the surface. So, and since the land use is not updated for the region, the model, when it starts the simulation, does not take account the buildings, for example, the height of the buildings, if there is a mountain in the middle of the way. Sometimes it takes account, the irregularity of the surface, it takes account, but in the vicinity of a city, it's difficult to represent the urban areas. So maybe if I compare my meteorological fields with some station from airport or from rural areas, maybe the model have a better match with observation near the surface. But in urban areas, quite difficult to have this match. And at the same time, the representativeness errors of the measurement station, it's other problem, because the flux of vehicle, for example, in marginal TET is too high. And since I adopted isotropic and homogeneous radius of influence, there is a better option to use in homogeneous and anisotropic radius of influence that can improve the analysis following the wind direction, the main wind direction, the main car flux in the region. So this would give me more details about how the pollution in that area can be better represented by the model. So I think this is the main challenge, is to use a better land use for the region, and also to have a better look to the representativeness of this station and adapt this station representativeness to the model, and put these representativities in the model. That way we can have a better understand about what's going on near the surface. But I'm not sure to say something like this. There is a lot of experts here, like Hendrik, Maria de Fatima, that I don't know if I'm saying something wrong or not.
Thanks.
Thank you, Ilan.
Okay, thank you very much, Ilan. And now Hendrik, please.
Yeah, thank you, Ediclê, well done. Ilan made me gnawing at my conscience about the challenge we posed on poor Ediclê. But Judith also emerged from my group, and we know what we are expecting, and we both also consider us as a little bit as a guardian angel of Ediclê. So when the progress he showed here was attained, then he was at least free to some degree to make this progress to a certain part, which evidently came to success. So again, well done, Ediclê, and also thanks that you also mentioned Anne-Caroline Lange and Philipp Franke, and also to some part Elmar Friese. First two are also part of Klimapolis and involved, and without the strategy in my group that the older group members helped the younger one, because in earlier years they were also the younger one, we know that it wouldn't have worked, and evidently it worked with Ediclê, and we have to find a strategy to make an innocent young student after a few years an expert on data assimilation. And also just heard Ediclê talking some keywords of data assimilation, which made me proud that you were so colloquially with them, and so it worked. Okay, the most interesting and central questions were already posed by Ilan, remarkably, but let me go a little bit into one step into more detail. And looking at the meteorological performance and which is input to the chemistry transport model, did you observe some effect of lacking quality, say in long-range transport, which has a poor impact on the chemical performance? Or do you think that the meteorological modeling was so perfect that first-order errors are only to be attributed to the chemistry modeling?
No. I think that I think meteorology affected directly in the not only in the transport but in of this pollution, but also in high levels of the atmosphere, but also near the surface. I would say that that it's necessary to use other meteorological provider like the ECNWF to say if to at least compare and see what's better work using or in EURAD for the region. And I'm not sure about how good is the GFS for the region. I know that there's a lot of other research groups that use GFS, but since there is different versions of GFS, I think there is a lack of, there are some errors that affect the final simulation of the behavior of this pollutant in the atmosphere.
If we have a look at the individual processes, so we have long-range transport from areas with agricultural burning, and then we have probably external transport along the valley of Paraíba, and then we probably have some sort of sea breeze effect. So are you content with both or all these three processes? Or?
For now, I am satisfied with the result, but it's necessary to perform a longer period to study, for example, the sea breeze effect in the transportation through the coast. And also between Rio de Janeiro and São Paulo, there is the Valley do Paraíba that is mainly composed by mountains, and that's there is some transport in between this mountain that it's difficult to be simulated. But I'm not satisfied. I think it's necessary to perform a longer period to really compare with other source of information to have a better answer if the model is correctly reproducing the behavior, or at least it's close to the real state of the atmosphere or not. I would say that I'm not I'm satisfied with the result, but it's necessary to simulate a longer period to make some more sensitivity tests to understand this transport, and also to see if the model is close to the observation or not in other levels of the atmosphere. So maybe what Ilan says about the sondage and radar would be nice to compare with the model simulated, and to see if it's really if I am performing better results or not. But for now, I'm not sure how well the model represented the long-range transport. for what I saw in other meteorological database and other studies, I would say that the model represented in a good way. But yeah.
Okay. If I remember correctly, you never addressed directly the question of boundary layer height. So we cannot measure or hardly measure emissions directly. We can only measure their concentration. And if the boundary layer height is at odds about a factor 2, then also the concentration is roughly of first order wrong. Did you have a look at the LiDAR soundings in terms of validating the boundary layer height of the model system?
So I used the LiDAR. I did not use a LiDAR sounders, but I used it. I just had some profiles, LiDAR profiles, which was validated by other group from IPEM, and from these profiles, it's very clear at that time that I use it. The boundary layer until the size of the boundary layer and the other different layers, aerosol layers in there, but I didn't not look the meteorology part to see the distribution of to better study the boundary layer behave. And so I'm not sure if I can correctly answer your question. Yep.
Judith, a last question is possible? It also makes a connection to Ilan's question about the representativity of the inner city measurements. So you know how it is in, meanwhile, you know how it is in Europe and Cologne, so we often talk about street canyons. And if the measurement site is inside the street canyon, the representativity is awful. But looking at Sao Paulo, where we have a lot of high-rising buildings, and the term street canyon, is it still applicable, or do the high-rising buildings even help to get a better mixture of what is emitted as a line source on the streets?
Yeah, that's a great question. I use the same methodology applied to Germany regarding to the representation of the station. And there, in your study, you put a table there, which is an advice to use the representativity and related to the radius of influence. And there's 1 kilometer for traffic. And I used this this radius of influence thinking, and in these sites, for example, Marginal Tietê, that are in a very in a intense traffic road, and when I use it 1 kilometer region of influence, the model has difficulty to represent the distribution of pollution in that region. So the complexity of megacity of São Paulo, for the complexity of a megacity like São Paulo, it's necessary to look deeply in this and even to elaborate a new representativity for the model simulate. Maybe changing, making some tests in the regions of influence, or even using another different approach for this region. But I think the urban area of São Paulo, it's challenging, and you have to know deeply if there is a street canyon in the region, since Marginal Tietê is near a river passage, and for other stations it's necessary to look more deeply in this representativeness. So yes, it's necessary now that the model working to look more deeply in each one of the stations to have a better representation of this station in the model. So that's it.
Okay, thank you. I'm done. Many thanks.
Okay, thank you, Hendrik. And I will pass the word to Fatima now.
I'll be closer here. First, I'd like to thank Ediclê and Judith for the invitation. It's nice to see your work. Also, I think your presentation was clear. It was a good, you could make a good overview of all the work. It was really nice. I also want to give congratulations, because we need young researchers, young investigators that want to work with modeling, and it is really nice to see that you are coming or going to this direction. I hope you keep working on that. It's nice. I think it's nice. I think everybody agree that we need more students that want to work with this, because it has a lot of difficulties, because you have to work with the data and the modeling and programming, and it's quite complicated. I understand that. And also we need students that want to work with getting data in the field experiments also, because this is another area that we need more people working. Well, this is what I like to start saying. And I took some notes, and I also make some notes to your test I will send you. But I will change a little bit about this. If I have time, I will. If I have time, I will ask about the other points. But one thing that I like to ask first is about emissions. The questions are more related to this kind of problems, like representing the surface. That's really a problem. And also the resolution, and also all these things. But another point that's very important always in the modeling, in the atmospheric modeling, is the emissions. And you include the vein emissions that represents more the traffic emissions. But one thing that I missed was this comparison, because you had the Edgar emissions for industrial, for the other sources, like I took here the notes now, when you see the description related to the emissions, you see that they put a lot of effort. I took some percentage here to some sources that we don't consider that they're main sources, even for São Paulo, like industrial emissions and other things like that. And one thing that there is a paper that was from people from South America comparing the Edgar with local emissions. And this is one thing that I would advise you to look in some details. And we have some emissions, some national emissions inventory from the Climate Observatory. And there we can find the emissions for different sectors, also including the biomass burning, but not only. including the burning of trash and other kind of sources that are more related to our reality. And then it can improve. Because when you said, for instance, the concentrations in Rio, and then you compare with the concentrations in São Paulo, and you said that the concentrations for PM2.5 is higher in São Paulo than Rio. But when we look to the data, and we have data for Rio de Janeiro, and you can find data for 2016 for Rio de Janeiro, and then you can compare that for some places, the concentrations of PM2.5, they are higher in Rio de Janeiro than in São Paulo. And then you discuss something like, we have more PM10, for instance, that are related to emissions. PM10 was there in your test related to, I think, industrial or other process like that, but you forget to say about the marine aerosol. You know, that is the, I think there, if you analyze the transport from São Paulo to Rio and Rio to São Paulo, and then you talked about the sea breeze, and then you forget to discuss that most of these coarse aerosols are coming from the sea breeze. You see, that's some kind of, that's not related to the modeling itself, but it's related to before the modeling, that's to see the comparison between the EDGAR and the National Emission Inventory. I don't know if you know this from the climate observatory that we have for Brazil.
No, I didn't look at it.
I will include this in the notes to say, because you will see that you can have even the emissions factor, and then you can compare. It would be nice to compare at the beginning, because this can explain some results that you are not finding in the at the end. And this is not this is always this happens, because what we see is that when we have these emissions, these global emissions, they consider different parameters to do this estimative. And then when we look to our emission inventory, we see that it's different. It's not the same. Even for the region close to the sea here, to the Cubatão and Santos, that we had a lot of industries. More now, the main sources, most for the places, are related to the transport sector because of the ports. You know, we have the biggest port of Brazil in the southeast of São Paulo, and the emissions there, you say, it's from the ships, because different from Europe, we don't have this control of this restrictive control of the emissions by the fuel that is used in the ships. This is not only here in Santos, but in other places. This is other thing that we have to study, because nobody is including and studying this. But this is a problem here in Santos, southeast of São Paulo, but also in the northeast. We have this problem with the ships. But as you know, it's not only the ships by themselves, but also all the transport sector, because we are a country that export a lot of agricultural products for outside, and then in the way these products are sent is we have the trucks, and then there's a lot of trucks. And then when you analyze the concentrations in Ponta da Praia, that's one station in Santos that's close to the port, there you will see that the concentrations are higher than in São Paulo. But it's not because of the ships, but because of all these trucks that they take every day a lot of things to the coast. I'm saying that because there are some specificities that it should be included in the analysis, because sometimes you don't know why the results are not so good, and then and there are different aspects that can be. I think one point that you have to include that's an uncertainty is not only the surface process or the canyons, but also the emissions. The emissions, they are really a problem, and we are facing now always this now. because of this, you're trying to include other inventories. And people from Paraná, they have an emission inventory for industrial process. Leila, Jorge, they had one, and they have one, and the students have published that. And I think this is, and I think it is one point that we have to study more. That is the representativity of the emissions in our model. I will do one question. Also, it's going to do other direction now about the representation of the aerosols and the secondary aerosols in the modeling, because there you describe a little bit about the MED, the model for the aerosol, and you describe a little bit about the inorganic aerosols. But I think it's not updated, your description, because you include only sulfate, nitrate, ammonium there. And I know this, all these schemes for aerosols, they include much more species, no? Oh, sorry. No?
Yep.
I don't know if you understand my question.
Can you ask again? I forgot. I missed your question.
I'm sorry. I talk too much. My English is not so good.
No, don't worry.
But it's okay. No, I said about I will do both questions about inorganic aerosols and the organic aerosol, because you said during the descriptions of this the description of the representation of the aerosols in the model, that when you have the inorganic, secondary inorganic aerosol formation, you said, yeah, many different parts of the test and also the reference, I think they are not updated. Because when you describe the inorganic aerosol, you only describe that you have the sulfate, nitrate, and ammonium as the secondary aerosol.
Yeah.
And also for the organic phase, you said that there is the formation of the secondary organic aerosols, but you don't speak nothing about that. And it's difficult if you don't have a good representation of the secondary formation to have a good representation of PM 2.5.
Okay. So the secondary organic aerosol and the chemical reaction, the calculation of these other chemical pollutants are made in the MADE. And the MADE includes also the sorghum model, the secondary organic model, aerosol model. And yes, I agree with you. Maybe it's not updated for São Paulo, for example. But in what I know is that the secondary organic aerosols calculated in MADE are responsible by 10% of the PM 2.5 concentration in the model. The other chemistry calculated in MADE, I don't know now I don't know how to answer you right now, but I can look at later and give you a better feedback about this. But I don't have an answer. Maybe Hendrik has a better answer about this, even correct what I said.
Just to add, as Ediclê said, for the organic secondary, we have MADE, which, by the way, was developed in Europe with EURAD, and the first one provided to WorfChem. and also sorghum. Sorghum is for the biogenic or for the organic secondary, and MED is for the thermodynamically driven anthropogenic one, which totally rests on the proper formulation of sulfur, hydrogen and nitrogen oxide, and ammonia. So if EDGAR is providing there the right emissions for that part, so would be the formulation and the simulation of the aerosols. So the key uncertainty is in the emissions there, but from the chemical mechanism, these matters provided. What is surely critical is the biogenic emission of the vegetation. So I guess this could be awfully wrong.
Yes, and also I think, okay, there was not time at this moment to look into secondary organic aerosols, but I agree that they are very important to look at. But also we are not aware of data available of secondary organic aerosols. Maybe they could serve to evaluate the model for the production. I don't know if there are maybe some experimental campaigns that you did in São Paulo with data that would be available for that.
Yes, now it's from the group of Pérola. Guilherme has he has published. He has the concentrations of organic fractions of aerosols, and it's in PM 2.5, and also comparing burning seasons with other periods of the year, and also, yeah, it's very complicated. I agree, but we have some data to compare, to see if the model is okay, and because the fraction of organic aerosols, if you put the primary, if you put carbon, elemental carbon and organic carbon, you have more than 6-7% of the PM 2.5 mass. It's a huge amount here because of this process of forming, and they are related to the fuels. We have a lot of emissions of toluene, benzene, now these species that they have a high potential of forming secondary aerosols, but also we have the biogenic emissions. I think it's not so easy to see in the city, but when we look to down the area that you have simulated, it can be important, because we have all the Serra do Mar and all this vegetated area, and probably it will be important also. But even for the city, we have this high amount of organic aerosols and inorganic, including elemental carbon. And because of this, I put this question.
Yes, I'm sure there's a lot of tuning to do still
okay, so we have to ask something, no?
Yes.
Professor Maria de Fatima, regarding to your another comments about sea salt, the model calculates also sea salt and mineral dust. I even calculated these variables in the model, but I was a bit afraid to put this result in the thesis, since I don't have data to compare. So I was afraid to affirm that the 20% of this particulate matter is represented by sea salt or even mineral dust. So I was afraid that some of you would ask, but how can you affirm this if you don't have data to compare? So, but the model has a lot of things to look at, and as when we have some database to compare with, would be nice to have this to put this in some in a work or in an article, would be very nice to put it. But since I have no data, I was afraid to put all this result in the thesis. Yep.
I think only when, okay, it's not 100% explaining the composition, but we now, there are some more papers describing the composition during the dry season, wet season, even for São Paulo, and also Rio de Janeiro. There are some papers there from Adriana Giotto, and she presents some composition also. It gives them an idea when we include it in the discussion, like, oh, there we see that there's, even for the official inventory, they include these emissions, like the profile, now, how much they expect to come from each kind of sources also.
Oh, excellent.
Thinking about the data that we have to be used for comparison. Well, I only I took some notes, but not to make it too long. I would like only to ask one thing. When you said about the concentrations at 158, the pressure level, what you look exactly? You took the column, or you took only one level, or you took an average of the level in the middle?
No, I took
my question.
Only the level at 800 HP, at 850 HPR. I did not took into account the vertical, the other vertical levels simulated in the model. So I basically only selected an area over São Paulo and calculated the flux between this area, but it was taken into account, but it was roughly conserved. And it was just an estimation of about the flux of mass between different areas of inside 1 kilometer. So it was just the total mass concentration of PM10 and PM2.5 at this level, but not necessarily deposited, sulfur deposition in over São Paulo metropolitan area.
Okay, I understand. Now, only at that level, exactly at that level, and see the transport between the two areas. Between you took the São Paulo and you took São José dos Campos and other.
Yes.
Oh.
Yes.
Okay. Thank you. I after I can ask a little bit more. Thank you, Ediclê. Thank you, Judith.
Thank you very much.
Okay. Thank you very much, Fatima. And yes, I also, I know we can probably not talk about everything in this defense, but you can send your comments also that are easily to be written down in the thesis to Ediclê after within the next days now. You can also send it to Ediclê, but maybe we have time for a second round. Let's see. So we'll pass the word to Tassiana now.
Okay, good morning, everybody. First of all, I'd like to thank Ediclê and Judith for this invitation. It's a pleasure to me because I have been working with them for a long time, and I can see how the growth of his research and also his personal evaluation. So congratulations. As everybody said, you work hard. I know that it wasn't easy these 4 or 5 years that you are doing your PhD. Also, I'd like to highlight the number of pages of your manuscript was only 138. I was surprised because you have a lot of results. So this could be much longer. So you could summarize your effort. Of course, many things that pass, but it's impossible to include every thought about the work. So congratulations about this center of the work. I agree about many points that was already put in here. mainly about the land use process that Fatima mentioned. That is not it's a big deal, but it's not the only thing that would improve the results. For example, we did for São Paulo, for instance, in São Paulo, we update our land use, not the urban area, but the land use about the vegetation. So we did this improvement already. And when we run WRF, the results wasn't that improvement. So also Fatima has students that improved the urban area using LCZ, and also we didn't see that much improvement of the results. So I think WRF as a meteorological, mesoscale meteorological model has some limitations. So when we try to compare one grid, like one point, one station with one grid cell, it's unfair, right? We want to prove that the model works well, but it's an unfair comparison. So I agree that the emissions file has a lot to do, especially when you are using Edgar. So there are many things to do. So I'm gonna pass some few points. Like I had my first question is here about the PM 2.5 composition that Fatima did, but in a different way. I would like to ask if you improve or use a different speciation of PM 2.5 that is Edgar put, because Edgar's file put more, for example, for PM 2.5, that POC is higher than PEC. And we know in São Paulo about the many data that experimental campaign that we have more POC than PEC, like more organic carbon than elemental carbon. The proportion is different from Edgar data set. So the question is, did you change this data, or you just use what Edgar put?
No, I just used the Edgar inventory because I was concerned about my time, my PhD time, so I didn't have time to improve Edgar emission. So I just prepared the emission for 25 kilometer domain, after for 5 kilometer domain and 1 kilometer domain, using all Edgar snaps and pollutants for PM 2.5, PM10, black carbon and organic carbon, but I didn't look at I didn't have time enough to improve this emission for different PM 2.5 scales.
Yeah. Like, I don't know about your model. In your pre-process, the emissions pre-process model, can you change this chemical speciation or not? Like, for example,
calculate.
Yeah.
Yes.
You could change there.
Yes, at MADE you can calculate different types of particulate matter in the 8CAN mode. You can differentiate. You can calculate organic carbon. You can calculate other different types of PM, and you can have an output of this species. But that wasn't my concern. Although I calculated these different PM 2.5 concentration, but I didn't include it in the thesis. I can put some results.
No, just a question, because as Fatima mentioned, is very important for us. For example, if you want to improve, to use EURAD for, as you said, for suggestions for future works, you said that we could use for future scenarios like emissions reductions. So how can, for example, if I reduce SO2 emissions could impact in PM 2.5 emissions. So how is this process into your model? If I reduce the precursors from PM 2.5, if it will work well, this connection, like.
Yes, as you have to change this in the emission you're using, like in the when you are preparing the emission, you can just take out SO2 or other chemical compounds in the inventory before it's simulated in the EEM. Am I correct, Andy?
Yeah, that is not the point actually, because I was thinking about how the model process, for example, the gas particle transition, for example. If you know, even if you didn't do in your work, but if you read something about previous work, if the model works well for this transition, if we could apply reductions and then the model will give us like a good feedback, something like that. If you just read in another paper or work, you know.
Yeah, I didn't look at carefully to this option.
Okay.
Sorry, do you mean to calculate different scenarios?
I mean, like, if the I'm asking this because when I did my PhD a long time ago with CIMEC, when we reduce, for example, SO2, almost nothing changed in PM 2.5, meaning that CIMEC on that time had a problem in this gas to particle phase, this transition. So I just could see a very good improvement, like reduction in PM 2.5 concentration, so particulate phase, if I reduce the particulate phase emission, because we could put in on the emissions file, we could process like as sulfate, nitrate, ammonia in particulate phase. So if I decrease on particulate phase emission, okay, PM 2.5 decrease the concentration. But if I decrease the gas phase, expecting that PM 2.5 will also decrease, but didn't show a lot of reduction. So I just was curious about how EURAD works in this situation. If I want to implement some reductions in precursors, how the concentrations of particulate phase will work, if well or not.
Well, from the algorithm, there's the full thermodynamically system with vapor pressure included. But there are some sensitivities on the temperature and also on the deposition and something like that. So there are a lot of possible influences which may impact that. But for the gas phase formation, the anorganic gas phase formation in MADE, which is, by the way, a model. So in the Aitken mode and the accretion mode, it's working. There we did not find a major deficit, so to my knowledge. But I'm not the big aerosol modeler, not at all.
Okay, thank you. Can I have more questions, Judith? I have time? Okay. About the assimilation data, I think you showed like a very good performance using, or sometimes improved. We can see that improved a lot the results. I'm curious about, like, did you do you know how many in percentage is this improvement? Because I don't know if I passed this, but this value, like, 10% increase or improvement of if you're using assimilating data or not. Did you?
Yeah, the main objective of data assimilation is to be closer to the observation as possible, and for this, when we perform data assimilation and try to solve the cost function you limit the number of interaction artificially. So the model will solve the cost function iteratively and will try to find the best, the most close as possible, to be more close as possible of the observation. So since the model takes this observation, assimilating the model in the model and distribute through the radius of influence, smoothing this concentration, when the error of the measurement and the error of the background it's too high, the concentration will can be pushed to one or another. But in general, the model pushed close to the observation almost 90%. And I did not calculate it how much for each hour the model are close to the observation, so I don't have this number, but we have an important improvement for some station that it's with a Pearson correlation of 0.995%. So it's quite near the observation. Henrik, there is a number for how much the model can be close to the observation or not?
Not can, but in your case, like, but you didn't, right?
It's because I performed two different tests using 1 kilometer radius and 2 kilometer radius of influence. I would say that using 2 kilometer radius of influence, the model were more close as possible to the observation in the end of the assimilation window. So it's hard to say because I don't have the exact number, but it's when we look into statistics and errors, we can see that the bias of the model was very low, and the root mean square was very low with data simulation. But I didn't pay attention and to calculate this number in US.
So taking this answer, what do you suggest for a city like Natal, Maceió, that doesn't have a very, actually in Maceió doesn't have any network station. So how could you implement or use your model without a good data set? Because São Paulo has the best network station in Brazil, but how
yes,
can we do it?
For cities like São Paulo, the best way is to use satellite from MODES to assimilate AOT or AOD. But since we don't have monitoring, air quality monitoring stations here, it's quite difficult. Maybe with this new low cost equipment that measure PM10 or PM2.5 concentration would be a good option to use in cities like Natal, João Pessoa, small cities. But would be nice to have some or even a measurement campaign would be nice to be assimilated in a model like EURAD-INVERSE. But yeah, it's necessary some database to perform 3D VAR. So for the Northeast Brazil, where the most difficulty is monitoring station, would be nice to do this by the remotely using MODES and other satellites that measures AOD, but without in situ measurement, it does not worth to perform 3D VAR.
Okay, one last question. You showed in your presentation a transport from PM2 concentration, PM2.5 concentrations, and you mentioned that probably it's coming from central Brazil. Did you analyze the boundary condition influence on this? Because sometimes when you put your animation, seems that comes also from the boundary condition. So how did you confirm, or you didn't, that this pollutant or part of these concentrations don't come from the boundary condition?
Yes, that's a good question. The other one was good also. Just a way to say. So the CAMS boundary values also include fire emission, but not in the grid of the model. For this, the better way to represent the fire radioactive power is to use the G-phase emission, which gives to the model the fire counts directly in the grid of the model. So, but when I look to Edgar emissions in that region, we can see that the agriculture, the SNAP 10 related to agriculture activity that include, for example, biomass burning activities from harvest from crops in the region, I can affirm that it possibly comes from biomass burning activity in that area. And I compared also, there is a graph in my presentation with fire hotspot from MODES, where you can see for that days that you have fire counts in that region. But I cannot be 100% sure that it's related to biomass burning.
And just to finish, EURAD has some not model, but process that is like a process analysis that you can, for example, choose one grid point and analyze these concentrations. For example, 10% came from emissions, 10% is reactions. Do you have any kind of this process to analyze the result into EURAD?
No.
In SEMEC, we have like a process analysis part. Yeah, because if you could see how like the percentage of each, like advection, emissions, reactions, and it's a good.
Like it's the source apportionment.
Kind of, but you could understand how that concentration was made or calculated. 10% of this or that. Hendrik wants to say something.
Yes, please, Hendrik.
Just a quick remark. This can be addressed. We are building up an ensemble system of our model. So this can help in a certain sense, but you should be aware, if you think in percentages, that's inherently thinking in linear terms. You also have interactions and feedback mechanisms, so that's easy to attribute percentages unless you make a fixed time instant as a development from time t1 to time t2. So, and I think by varying ensemble configurations, let's say by giving a delta to some emissions plus or minus or other processes, it would be possible to achieve that what you request there. And this beyond the fact that ensemble per se are for the future a good indicator of some error ranges and so on.
Okay. Okay. Thank you, Judith and Ediclê. Congratulations again.
Thank you. Judith, can I have just 1 minute interval?
Yes, so, okay, so thank you very much, Tassiana, and we will make a very short break and then come back in
1 minute.
Yeah, at 10:45, okay?
Oi, Ediclê. Ediclê?
Oi.
Tudo bom? Você viu aí os recados que eu coloquei aí com relação ao seu microfone, né? Ele está roçando na sua roupa e volta e meia faz aquele barulho de fundo. Só é você fixar ele na sua roupa que fica legal.
Tá bom. Tá melhor assim?
Se você fixar, melhora.
Tá
isso, fixou, né? Agora melhorou, viu?
Fixei, tá bom. Mas
mandei
estava assim
vários
durante
recados
a
aqui.
apresentação inteira?
Tava. Eu mandei vários recados assim para você, mas tudo bem. Tava ok, tá?
Tá bom,
ok.
tá certo. Nossa, desculpa, é porque eu tava nervoso, nem olhei a...
Mas não tem problema. Tá tudo ok. Isso é normal. Só aguardar o pessoal retornar aí e a gente retorna. Para você não ficar sozinho aqui, eu vou aparecer também aqui na tela, só para você não ficar sozinho aí.
Tá certo, obrigado.
Tá bom aí, para ficar na tela, porque a gente ainda está ao vivo, ok? E eu ainda não cortei o sinal da transmissão. A gente só vai cortar na hora que a banca for se reunir, ok? A gente já avisa de antemão para o pessoal que a gente, durante o momento em que a banca for se reunir, a gente coloca o Ediclê numa sala de espera e a gente corta o sinal lá do Facebook. Okay? Facebook não, desculpe, do YouTube.
Eu permaneço aqui, só que você me corta, não é isso?
Eu vou cortar você e vou colocar você numa sala de espera. Lá tem cafezinho, chá, tá certo? Uma paisagem bonita assim, a música de fundo. Você vai ver, você vai gostar da sala de espera.
Tá bom.
Tá? Nem se preocupe. Judite, retornamos, né, Judite?
Sim,
eu vou ficar conversando aqui com o Ediclê, porque a gente está ao vivo e ele estava sozinho aqui, coitado,
sim,
né?
Sim. Não sei se o Ilan já está aí. Ilan, are you there?
Ilan tá também.
He's also back. So, okay, so we can retake. So now I will pass the word to Nilton, please, Nilton.
Good morning to everyone. First, I would like to thank Judith, Ediclê, and Claudio for the invitation. It's really a pleasure to be with you for this defense. I'm going to repeat what the other members said because it deserves it. You did a great job, Ediclê. I think it was a challenge to put all these things together, work with modeling, observation, assimilation in a difficult context, in a challenge context, which is São Paulo. And on top of that, you selected tricky meteorological scenarios. So you did push the model to work in a difficult environment. So I will congratulate you for that. I think from the point of view of your formation, you now have an understanding, knowledge from the point of view of this topic that you are working compared to when you started. So definitely, I think your formation, it's highly evaluated from this point of view. Ilan said that the wrong results, the bad results are the best, nice to see. I do agree. And I add to that also the good results for the wrong reason also. You have to look at that. And sometimes we have good results, but for the wrong reason. That's why we need to check in details all the aspects that are involved in this discussion, meteorology, emission, and be sure that what you are seeing in your model is consistent with the methodology of your model. It's consistent, so it's something nice to see. And I think most of the questions that I think are good questions were already done. But I was curious about a high concentration of PM2.5 in the middle of São Paulo state in one of your simulations. It was an extreme event of, it looks that it was an extreme event of biomass burn, I'm not sure, around Bauru region, on Ribeirão Preto region, somewhere. And at the surface level. But when I was looking at the 850 hectopascal, I wasn't able to see the signature of that extreme event. And then I was thinking about how the emission from the point of view of the injection, it's performed in the model, how this model works from the point of view of this injection of the pollutants. Is it all injected within the boundary layer, or there is some dependence on the fire radiative power or the thermodynamic of the atmosphere? Because that is going to do a lot of change from the point of view of the layer that the aerosol from outside of São Paulo is being transported. So I'd like to know about that, about the injection layer, how it is considered in your model.
It's difficult to explain, but yeah, that's a great question. Yeah, the model used all the advection equation from CTM to inject pollutants in the boundary layer in all other layers of the model, taking into account temperature and the boundary layer height. But I'm not sure right now how this mechanism works. It's a complex mechanism, and yeah, I don't.
No, because
that's my answer right now.
No, because that's going to be mainly from the point of view of biomass burning. Certainly, the level of injection will impact the level of long-range transport, even regional transport, I would say, over the atmosphere column of São Paulo. So that's something I was curious about, the comparison between LiDAR profile and the model profile. And I think you mentioned it somewhere. I'm not sure if it was in your presentation or in your paper, your article, which is congratulations for that. You already published some papers. That's really good. That's outstanding. But I would like you to, did you check this profile from the model and from the LiDAR? Did you compare them?
No, I didn't look at so deeply to this mechanism of injection in other levels of the atmosphere. It was yeah, that was my error. I just trusted in the model mechanism, but I didn't look deeply how this mechanism worked. So I can look at after, but I don't know, maybe Hendrik knows, or I'm not sure about how to answer correctly this question.
As far as I know, the G5 fire emissions, they already come with the specific injection heights. I think it's, as far as I know, it's included And Ediclê actually knows that we've been talking about that, but I think he's getting a bit
Yeah,
tired.
Don't worry.
yeah, you are right. You are right.
So the injection heights, different injection heights of different kind of files, they are included by the GFAS database. But nevertheless, even if we have injection heights included, we need to check if the vertical distribution in the model is, you know, if we look at profiles from LiDAR, for example, or other data where we have a horizontal resolution, maybe Calypso data, and to see where in which heights the aerosol layers are located. This is another thing that needs to be done, definitely, to compare if the height distributions of the aerosol layers, if they confer with observational data, for sure.
Yeah, that's something that I would suggest, because you had AeroNet here in São Paulo. I was surprised I didn't see AeroNet data, because it tells you a lot about the arriving of the air plume, the smoke plumes from outside of São Paulo. If you combine that data with surface data, you maybe will see the different behavior, which allow you to think about, well, if concentration is not increasing at the surface, but the AOD is going up, maybe there is transport over the boundary layer. So that's something that I would suggest to look at, this combination between AeroNet MODIS and LiDAR, and also surface measurement, because it's going to teach you a lot about if my good result it's due to the right reason or it's about wrong reason. So that's something that I would suggest you to do. Yes. Because the first case that you studied, that was in July, the AOD wasn't that high in your LiDAR map. You can see it. It was 0.1, you know, 0.15. I think the highest value that you should, and that's something very normal for São Paulo. That's something expected for São Paulo. And in the other case, the October study, indeed we had a high amount of aerosol over the plume in São Paulo. In that case, it seems that there was an important transport. For the first study case, I wasn't sure about the importance of that outside transport of São Paulo. So that's one of my questions. The second one, finished. It's about something that was already discussed, but I would like to emphasize, which is meteorology. And it seems that the model, it's cooler than the observation. The temperature at the surface, it's cooler than the observation. And that's not something specifically for São Paulo metropolitan area, isn't it? Am I right?
Yes, you are right.
It's cooler. It seems that it's cooler everywhere.
Mm-hmm.
And it seems also that it is a bit windy compared to the observation. I would like you to think about these two aspects from the point of view of your background, because you had a cooler atmosphere at the bottom, and you have a windy scenario compared to the observation. And I would like you to include in this analysis the fact that your model is able to predict coarse mode aerosol from ocean and also soil resuspension. Yes, how that may impact this windy scenario that we saw in your model may impact your analysis, and this temperature from the point of view of you have a cooler atmosphere at the bottom.
Yep. So the windy scenario can contribute in a good way when the wind speed and direction match with the observation, and this and because of this we have a more consistent concentration more close to the observation. But if the wind direction simulated by the model it's too different than the observation site, it can have an important impact in the concentration calculated in that point of the station that I'm comparing. So basically, I think that the meteorological condition in October had a negative impact in the calculation of the concentration. Maybe because of the wind direction was too different than the model, so the pollutant plumes were pushed to other region and spread to other direction than the direction of the station in that point. So it's necessary to perform for the same period using different parameterizations to see if the model works for one type of meteorological situation. The model works with this set of parameterization. In another case, the model can work with a different convection parameterization, for example. Yeah, I would go that way.
I mean, from point of view of temperature, if you have a cooler surface, definitely that has to do with it will affect your PBL development, and or at least that will affect your atmospheric stability. That's something that you may think about. And about the wind, it's complicated. Indeed, it's complicated because it's not just about the velocity; it's about also the direction. So that's what something that I would like to emphasize here. Along, of course, there is this issue related to the stations that were selected, and something that it's very clear about your thesis is that how can we, in a clever way, select a station that can be used to evaluate model? Do we have this station in São Paulo, or most of our stations are not in a proper scenario to evaluate model? So these are questions that I realized from your thesis. It's not just about air quality station. It's also about meteorological stations, because not far from my house there is a station, CT station. The sensors are below of a tree. There is a tree above the station. So how are you going to evaluate the temperature of that station? So this is something that we can learn a lot from your thesis, that we need to think about that, how to develop a network proper to check models. And I hope that that's a good lesson that you are taking from your research.
Yeah,
I think.
Yeah, thank you. It was one thing that I talked with Judith before comparing the model and the observation, and we thought that would be more representative if we clustered this station that at least were nearby, because that way we thought that comparing with the model would be more representative, because like you said, when you compare one station with what the model calculates in the same point, it's sometimes if the station are above or there is a tree over the station, it's quite different to the models.
But I think model definitely all model have this problem, And I think you did push this model. I think that's an important one. I would like to see its performance in a different meteorological scenario, let's say, where to understand some basic steps. And also, I would like to see this selection of station in a better way that you could examine, you could evaluate your model, because I was thinking about why Diadema it's classified as a MASP center along the Marginal Tietê. They are different sites in a different place of São Paulo. So this may be something to think about. Okay, Judith, I think I'm done.
Okay.
There are other questions, but I'll send some of them by mail.
Perfect. Okay, thank you very much, Nilton. And you made a very important point, and I think that we will need more advice from São Paulo specialists, maybe to cluster better the observations and get a few more ideas about which stations are more representative. And I think Tatiana wanted to comment something. You raised your hand.
Just about what Nilton said about the modeling evaluation and the stations. One point that I don't know if you, Ediclê, take a look about the first level. So what is the height of your first level in WRF? Because Rizieri made many tests using 4, using 10, using 20. And when you compare with the station, this varies a lot. So if you use 20 as a first level, if I'm not wrong, the model put in the middle, so it's 10. But if you change this number, maybe we'll change when you compare with the data set. So maybe this is a point that you can check, that gonna help you to discuss your results.
Thank you very much. Yes, I'll look at. But the same high I use it for WRF, I use it to the city. I mean, my first level has 35 meters high.
Yeah, but about the wind, I'm talking about the wind speed, for example.
Okay, it was 2 meters.
No, 2 meters is the result that WRF give to you, but the size of the grid cell, your first level, is not 2 meters. So just check about that and try to explain better the results.
Okay.
Okay, thank you very much. And now I will give the word to Ediclé's co-advisor, Cláudio Moisés. Cláudio.
Good morning. I thank you, Ediclê and Judith, to participate in your work. I am officially a co-advisor, but I confess I did not participate in some stages of the project, so excuse me. But if you still need, I am available to collaborate wherever is necessary. Okay. I have no cash about the project because everyone here made the excellent comment and suggest, in my opinion, your project involves many processes, physical, chemical, geographic, meteorological, among the other processes. And it's in my opinion, is one of the best work developed here at the PGCC. The collaboration with colleagues from Germany was excellent. You know, I was skeptical if you could finish the project completely, and you proved that I was wrong. So I really happy to see the quality of your research. I can only say congratulations and so good.
Thank you, Professor Cláudio.
Ok.
Eu acho que o seu áudio está
Seu
desligado.
microfone, Judith.
I said, thank you very much, Claudio, and I'm also very happy to hear that, that you like the work. And but we still have time if you want to ask a question or comment anything more detailed. No, not at the moment. Okay, thank you. So, okay, so we completed our first round. And if there are still comments that you find important to make in the defense and or questions that may have arisen, we can still go for a quick second round, or if someone is interested in saying anything else. Anyone?
Judith, can I ask a small question?
Yes, sure.
I know that Ediclê is tired, and I would be tired as well after such a long session. So it's a curiosity. It's not related to your work, but do you have a way to translate the aerosol concentration in your model to AOD, to create a equivalent to a satellite image map?
Yes, there is an equation in the model who can transform PM concentration or PPB to AOT. If I'm not wrong, I'm right, Hendrik. I'm sure that I saw this equation.
Yes, therefore, in data simulation, in parlance, we call this observation operator, that we can simulate how the model would see in terms of different remote sensing sensors the result. And we can, with the adjoint of this, we can put it back into the data simulation part.
Because this may be a very good way to, as others, I think that Nilton said it, but I think that in very sophisticated terrain, this could be a very nice way to validate the data. But you have to be careful, because you have to use full radiative transfer equation and to know what are the optical properties, what are the right optical properties and size distributions of your model, and to calculate reflectances accordingly. But this could be a very nice way to validate the performance of the model.
Yeah, this is, meanwhile, this is done in state-of-the-art model. So you simply, in quotation marks, simply rely on the configuration of the aerosols in your model. And then you have a radiative transport model, but there are also some shortcuts of this with reducing complexity and additional assumptions. The most striking point is that the satellite sensors have their own radiative transport model, and this should be adopted. And in practice, you have also to build the adjoint of this, and then you can be sure that you have some at least consistent. Whether it's close to the reality is a lecture which must be learned by the results.
Yeah. Thanks. Thank you.
Thank you, Inlan. And anyone else with another comment, another question?
Judith, actually, the last one, just to, I mean, it's a question that was made already, but I want to emphasize it. Ediclê, if you want to highlight an aspect of your result, a specific result that you would like to take to work on for the next year, which one would be from this, from your contribution that you did in this thesis? If you would like, if you had to select, if you have to select one particular aspect to go on, which one will be?
I would say that the 3D VAR, to put the 3D VAR to work was amazing. It was challenging. It required a lot of interaction with Hendrik's group. And at the same time, it's very hard to understand what's really is data simulation in a mathematical and physical way. It's not easy. So it was very difficult to put everything together to work. I know that the model has its limitation, and not everything are finished yet. It's necessary to work on the other important things that are missing. But it was very important to put the data simulation to run over São Paulo, because there will be, I'm writing already another article of data simulation, and there is no work about 3D VAR or 4D VAR assimilation of PM concentration over São Paulo. There is only one work using 3D VAR applied to the Northeast Brazil. That was another Judith student. So, and there is another Judith student that worked with 2D VAR assimilation in a campaign in Mato Grosso do Sul. So I really like this work, because we can be pioneer to explore this new research field in Brazil. So it makes this thesis very important, not for me, but for Judith group and for Hendrik's group. And I always think that a good way to pay back all the help, all the effort in this work is to write good article and to publish good article. It's a good way to pay back all the help and support I had during this PhD. And I'm satisfied, because now we have 3D VAR working over São Paulo. And in the second article, we'll explore PM10, PM2.5, and ozone over São Paulo. And it will be a great work. And so I'm very happy with this. And so the main highlights is data simulation, because it's not easy to do, and required a lot of interaction between me, Hendrik, Judith, Philip, and Annie. So it wasn't done only for me, but it's nice to have this working right now, and we just have to fix some stuff in the model code. And now we are writing, and the mission, and the mission. I have to put the GFAS emission to work in the model. It was so many stuff during this 4 years of 5 years of PhD that it's difficult to put everything to work, because the time is passing and it's limited, and I'm not a genius or an expert in data simulation or in modeling. I have to learn from the zero since the beginning of my thesis until now, and it's challenging. So yeah, I'm happy with the result, and we will take good fruits from this new advanced technique applied to São Paulo state. So yeah.
Okay, anybody else? Fatima, do you have another comment? Tatiana? No? Hendrik? No? Okay, then I will just find some final words as the main supervisor of Ediclê. and I'm going to improvise here. Ediclê, I also want to congratulate you. You had a really challenging topic and you did an excellent work. There will always be open issues and construction areas where you need to improve. But I think that the main task was to put the model to run, to put the data simulation to run and evaluate both the chemistry and the metrology, right? For first to put it to run. And now we can work on details and dedicate ourselves to individual construction areas like improving emissions with more locally available data from MASP and maybe Rio de Janeiro, and we can do a lot of different studies now, but the tool is now really working. So we had one former student in our group, Aline. She put the model to work also with 3D VAR for the satellite product AUD over the Northeast, but we also have the problem with satellite data that's not evaluated over the region. And so at the moment we have expanded work group who's working on analyzing the different satellite data that is available. And Nilton is part of that group, and Ediclê is also will be participating more now after his defense. He has more time to participate in this aspect. And so in the future, we plan to include different sources of observational data, not only Tese, but satellite data, and use the vertical profile data that we have to see if the vertical distribution, if the model gets it right, and further investigate the biomass burning emissions from GFAS, and if the injection heights are correct for our needs here over South America. Anyway, there's a lot to do, right? But the main point is that you did a lot, Ediclê, and really it is a very complete analysis. You did very fine statistics for the evaluation, and it's a very complete study. And we had former generations of students working with EURAD, but you are the first one who really put it to work with a thorough and detailed evaluation, you know. And so from now on, we hope that we have this, what was mentioned before, that the older generation pass it on to the younger generation. So this is something that we didn't manage, you know. I think Henrik mentioned it, that when you have a working group, you need that the older students pass their knowledge over to the younger students about putting the model to run and implement stuff, and you know, share what they learned. And this is especially important at a university where we don't have workers that we have students and we have professors, but we have very few people in between. So sometimes we have some postdocs, but at the present situation in Brazil, you know, the grants, they just get cut and we lose a postdoc from 1 month to the other without any way to plan that in a good way. And so we need the collaboration of the students between the different generations. And this is something that before some years before, when we started to work with the EURAD model, did not work so well, because we had students who were not so eager to sit with the younger generation and pass the knowledge on. And now finally we have, you know, we reached really a milestone with the work you did, Ediclê. So now we are exploring this knowledge transfer, and it's working. And I hope that with Gabriel as the next generation, I'm sure that it will also work. And so I think we are now on a good way to be more productive with our studies related to the model and to the data simulation. So I'm very satisfied with your work, Ediclê, and I know you did a great effort. You still had the pandemic to deal with in the last year, and this also related to problems with the supercomputer that was hacked and couldn't be used for many months. And so there were a lot of issues. And if we look to all of it, you did an amazing job. So thank you very much. It was very satisfying to see your defense today and your presentation. And with these words, I would like to move over to the last part now of the defense, which will be the discussion whether you are approved or not, Ediclê. And we will need you to leave the room. So Aguiar, you will put you in a waiting room. And,
Exatamente, Nobre.
and we will call you back.
Ok, eu vou colocar agora você na sala de espera, Nobre. Enquanto isso, a gente vai cortar também o sinal aqui do YouTube.
Tá certo.
Tá bom. Ok. Vamos cortar também o sinal do YouTube.
So we are back and Ediclê is also back. And so we try to be brief in our discussion, Ediclê, and I want to inform you in name of everybody of the examination board that you are approved and you have 1 month to do your corrections and hand in the final version.
Can I say some words?
Yes.
Now, first of all, I want to say thank you to each one of you to evaluate my work and to be participating of my examining. It's not every day that we put together a lot of great scientists, and like it has been amazing. And I was a bit nervous about my defense because there's great scientists here, and I want to say thank you to each one of you. I want to say especially thank you to Hendrik and his group for all the support and help during my stage in Germany, and also all the time that I needed help with something, the model, some doubts, they were available to help me, especially Hendrik, Philip, Annie, and Elma. So I cannot forget them because it was not a work of one person. It was a group work, and it's good to be here, and it's good to say thank you. And once again, it's good to pay back with good work, with good article. I want to say especially thank you to my professor, Judith. Judith has been my supervisor since my master's degree that I started 7 years ago. So she stayed by my side every step of the way, and she gave me all the opportunity I needed to conclude this work in a good way and to perform a good job. So I was lucky enough to have a great supervisor, a great scientist, a great mentor by my side. And I want to say thank you, especially to Judith, for being by my side and helping me in every step of the way. And I'm very grateful. Thank you very much. And there's a lot of work to do. I will dedicate my time to the second article. It's really important for me, and it's important to EURAD group and to the Climapolis group also. So thank you very much. It has been a long road to this moment. So I'm very happy. I confess that I need at least 3 days off. My right eye is trembling, like because I'm very stressed with all this work, but it's worth it. It's worth it every moment. So thank you very much, Judith, Hendrik's group. Thank you all for reading. I will accept all your comments and critics because I'm 100% sure that we will enrich my work and it will contribute to future articles. And yeah, so thank you very much for everything.
Right, Ediclê, thank you. I'm moved. It's a nice feedback when you, as a supervisor, also invest a lot of effort and time, and it's nice to hear what you said. So thank you very, very much, and I'm looking forward. And of course, you can take 3 days off. You will need it, I'm sure. Everybody does after a defense. Okay, guys.
Just a quick remark from my side. Also, yes. Judith is an expert on data assimilation. She had a very theoretical topic as her master thesis, and it should not be the impression here that it was all done here in here in Germany. Also, EURAD has a very tricky expertise in this stuff.
For sure. She was by my side every step of the way until yesterday when I sent her my my defense presentation to give me a lot of comment, and in 3D VAR, she was with me in every meeting, in every interaction with Hendrik's group. So she participated in every step of the way.
I'm getting the impression that I defended the thesis. Oh, thank you, guys.
Yeah.
Okay, so anybody wants to say anything? Or everybody's
congratulations. Congratulations for you both.
Yes.
It's impressive about the job.
Thank you very much.
Congratulations, Ediclê, Judith.
We are looking forward to many more collaborations with all of you on future works within Klimapolis or other projects or centers. So yes, so thank you all of you very, very much. And I will release you now for your lunch and after this very long meeting. So thank you all very, very much. It was a very exciting defense, and I hope to see you all soon, and keep healthy, keep well, you and your families, and you all take care. So
Thank you. Bye-bye.
Bye.
Take care.
Ok,
Bye, guys. Bye.
Thank you.
tarefa cumprida. Eu pedi licença agora aos nossos espectadores para encerrar a nossa transmissão.